For this one, take your grams and take your MR and convert that into moles. That's how many moles you've got in 250 centimetres cubed, but actually only 25 was used. So you've only got a tenth of the moles because only a tenth of the solution was used. So divide your moles by 10. That tells you how many moles of your K2CO3 were used. But then you've got to consider that for every 1 mole of K2CO3 that is used, 2 moles of HCl are used. So you need to double that number to find the moles of HCl. If we know the moles and we know the concentration of HCl, then we can work out what volume of HCl was used. The next one is similar. If I know the grams and I know the MR, I can work out the number of moles in 200 centimetres cubed. But again, a tenth of this, 20 centimetres cubed, was used, so I need to divide the number of moles by 10. That number of moles reacted with 20 millilitres, 20 centimetres cubed of concentration 0.17 moles per decimetre cube HCl. At this stage, I'd probably look at how many moles I've actually got of that HCl. So moles equals concentration times volume, remembering that the volume needs to be in decimetres cubed, so don't forget to divide this 20 by 1,000. Then I can look and see which one is in excess. If it's saying that the resulting solution from these two things reacting together is titrated with NaOH, I'm probably starting to think that actually some of that HCl is left over, the HCl was in excess. So then the excess, the leftover HCl, will be what's titrated with this concentration of NaOH. If I know how many moles of each of these two things was used, knowing that it reacts in a 1 to 2 mole ratio means that I'll be able to work out how many moles of the moles in 20 millilitres of 0.17 concentration were actually used up, and therefore how many are left over. The moles that are left over of the HCl will react with the same number of moles of NaOH. If I then know the moles of the NaOH and the concentration of the NaOH, I can work out the volume of NaOH that was used. Here it's similar again. Grams, MR, turn that into moles. Volume, concentration, turn that into moles. Then bearing in mind the 1 to 2 mole ratio, think about how many moles of acid will have reacted with those moles of CaCO3, and therefore out of the 15 millilitres of 2 moles per decimetre cubed, how much will actually be left over, how many moles will be left over. Then, bearing in mind that that's the moles that are going to be made up. If you know how many moles of your CaCO3 have reacted, then you know that twice as many moles of your HCl have reacted. That means that you know how many moles out of this amount here reacted, and therefore how much is left over. That leftover acid was used to make a solution, but only 20 out of that 250 was used. So only 20 out of 250 of that leftover acid moles was used. That means you know the number of moles of leftover acid that were used, and you know that that reacts in a 1 to 1 ratio with the sodium hydroxide. That means you know how many moles of your NaOH reacted. That means you know the moles of your NaOH, and you also know the concentration, so that means that you can work out the volume. In this one we know the mass, but we wouldn't be able to work out the MR because M is the unknown metal. However, we know that that mass was dissolved in 100 centimetres cubed, and we know that only a tenth of that was taken and reacted with 25 centimetres cubed of HCl. We then know that in that reaction there will be some acid that reacted with the M2CO3 and some acid left over. The leftover acid will have taken 19.9 millilitres, 19.9 centimetres cubed of 0.1473 moles per decimetre cubed concentration NaOH to neutralise. If I know the number of moles of my NaOH by using moles equals concentration times volume, if I know the NaOH moles, I know the HCl moles. The HCl moles is the leftover HCl. If I know the leftover HCl and I know how much HCl was originally there, then I can work out how much reacted. The amount that reacted, the number of moles that reacted, is what you'd find in 10 centimetres cubed. you have to times it by 10 to get it up to 100 centimetres cubed. If I know how many moles of HCl there were in 100 centimetres cubed, then to find out the number of moles of M2CO3, I would have to divide those moles by 2. If I know how many moles of M2CO3 I've got, and I know what mass of M2CO3 I've got, then I can rearrange moles equals mass divided by molecular mass to find out what my MR is. For the next one here, I know that this volume and this concentration of NaOH reacted. If I know how many moles of NaOH reacted, I know how many moles of HCl reacted with that. So I know how many moles of HCl there were in 10 centimetres cubed. If I know how many there were in 10, I know how many there were in 100. And that's how many moles were left over from the 20 centimetres cubed of 2 moles per decimetre cubed acid after the reaction. So if I know how many moles were left over and how many there were originally, I can work out how many moles reacted. As soon as I know how many moles of this reacted, divide by 2 to find out how many moles of this reacted. If I know the number of moles and if I know the mass, again, moles equals mass divided by molecular mass, rearrange to find your molecular mass. If I know that the molecular mass is a certain value for MOH2, if I take away the 2 OH masses, so if I take away 16 plus 1, 17, multiplied by 2, 34, then that means that the remaining number is going to be the atomic mass of M, the metal. Again, remember these are back titrations, so work backwards. If I know the volume and the concentration of my KOH, then that means I can work out the number of moles. If I know the moles of KOH, I know the moles of HCl. That was the HCl in 25 centimetres cubed. So then I need to think, if I know it in 25, what do I need to multiply to find out how many moles were in my 200? If I know the moles in 200, remember that's the leftover from the original 20 centimetres cubed of 2 mole per decimetre cubed of our HCl. If I know what was left over, I know the original, I can work out how many moles of my HCl actually reacted. Then iron can either be +2 or +3. So straight away I'm thinking N isn't going to be 1, it's going to be either 2 or 3. So try it. If N was equal to 2, and then I had the MR where it was FeOH2 and the mass here, then I could work out the number of moles and I could see whether that fitted in a 1:2 ratio with the number of moles of HCl that I know reacted. If that doesn't work, then think actually it might be that N is 3. So try it with 3 there, work out the MR. If I know the MR and if I know the mass, I can work out the number of moles, see whether that fits in a 1:3 ratio with the HCl.